At its core, developing programming code involves translating a problem or a task into a series of logical steps that a computer can understand and execute. Here's a breakdown of the key steps involved in the process. Understanding the problem. Before writing any code, it's essential to fully comprehend the problem you're trying to solve. This involves understanding the requirements, constraints, and expected outcomes. Algorithm design. Once you understand the problem, the next step is to design an algorithm or a step-by-step procedure for solving it. This involves breaking down the problem into smaller, manageable tasks and determining the logical flow of the solution. Choosing the right tools and technologies. Depending on the problem domain and requirements, you'll need to select the appropriate programming language, libraries, frameworks, and tools to implement your solution effectively. Writing the code. With the algorithm in mind and the necessary tools chosen, you can start writing the actual code. This involves translating your algorithm into a specific programming language, following its syntax and conventions. Testing and debugging. After writing the code, it's crucial to test it thoroughly to ensure that it works as expected. This involves running different test cases, identifying and fixing any errors or bugs, also known as debugging, and refining the code for better performance and reliability. Documentation. Documenting your code is essential for future reference and for helping others understand how it works. This includes writing clear comments, providing explanations for complex logic, and creating user manuals or guides if necessary. Optimization and refactoring. Once the code is functional and tested, you can optimize it for better performance, readability, and maintainability. This may involve refactoring code to improve its structure, eliminating redundant code, and applying best practices. Version control. Using version control systems like Git helps you manage changes to your code base, collaborate with others, and track the history of your project. It allows you to revert to previous versions if needed, and ensures that changes are made in a controlled and organized manner. Continuous learning and improvement. Programming is a constantly evolving field, so it's essential to keep learning new technologies, languages, and best practices. Stay updated with the latest developments in the industry and continuously strive to improve your coding skills. By following these core principles and practices, you can develop efficient, reliable, and maintainable code for a wide range of applications and scenarios.